Hi there, my name is Zachary Hecker, part of Team Kepler with Rachel Larkin, Savannah Taylor, and Jennifer Hart. And today I'm going to be showing and demonstrating my transport robot, the last robot in the swarm for finding artifacts in icy polar regions. Our concept for this robot was to look for different artifacts that are frozen in icy polar regions using a artifact dislodging robot, an armed sled, a search robot, and a transportation robot to make this successful. The transport robot meets with the artifact dislodging robot to collect the artifact. It securely stows the artifacts, avoids obstacles, then delivers the artifact to the base location and uses adaptive lighting to illuminate its path. So originally I had planned to have a truck bed cover on the top of it and a distance sensor on the back as well as a camera on the front, but this was all very difficult and time consuming to incorporate with the amount of time we had and in Tinkercad, so I eliminated those and it made it a little bit more simplified. And here you can see the distance sensors, some of the lights, the photoresistor, the battery, and the wheels on which the truck rides on. And with this better close-up view, you can see the servos used to turn the front and rear axles independent of one another, and you can see the DC motor on the middle axle to drive the transport truck. And with this view, you can see the Arduino board, the 9-volt battery, the distance sensors, and the photoresistor and LEDs. And with this circuit design, you can also see the 3 distance sensors, the 2 servos used for steering, the DC motor, and the 9-volt battery, as well as a breadboard and a H-bridge for the DC motor to communicate with the Arduino. The Arduino code, it's the last robot in the swarm, so it receives input from the operator and it changes its mode whether the artifact has been received or not. It uses programmed information to find its home base, and it avoids obstacles and uses light as needed to do this. And here you can see my main loop function, which calls my other lights and steering functions. And on the left, you can see my void lights function to turn on and off the lights. And here we have the steering function, which uses other turn right, turn left smaller functions and uses the algorithms to figure out which way to steer the truck. And here in my Arduino code, you can see my initializing all the pins and the numbers using names, which makes it easier to edit the code, as well as initializing whether they're input or outputs. And then here we have my first void loop, where it takes string in from the user, and if the truck is identified as loaded, it will then start driving forward. If it's empty, it will stop, and then it will tell the user to wait for the artifact to arrive. And if it's returned, it will let the user know that the artifact has returned to the base. And here you can see the little startup function, which just prompts the user to enter their text. We have the checking distance function for checking the distance from the front, left, and right sides, the forward, the stop function, the light function I described earlier, the steering function, and the turning left, turning right, and no turning functions. Budget-wise, I just found some optimized costs for Arduino kits online. So this was the best bet, because if you were to price this all out individually, it was very expensive. So this is a great way for a beginner user to also start their own Arduino project. So here we have the demonstration of my code, where it's prompting me to enter either load, unloaded, or return. So I typed unloaded first. Now I'm typing in loaded to let them know that the truck is full, and you can see it's now driving. So I'm first testing the LEDs to see if the brightness and the ambience responds to the photoresistor, which it does. And then here I'm cropping and I'm zooming in a little bit on these distance sensors on the front, and I'm going to demonstrate by having the distance less than 20 inches on the front, and then having either the left or the right side bigger or smaller. It will show the servos turning different directions, the front independent of the rear. And as you can see, the motor is moving right now because it is driving, and you can see those servos turn as I adjust those distances. And finally, Just demonstrating again about the servos. And now we're going to turn in returned, and that will show that the truck has returned to the base, and that motor will stop, and that's it. So summarizing about this swarm for excavating and finding artifacts in frozen regions, it's a modern tool for doing such tasks. The robot has autonomous movement and location communication purposes. It's part of a team with other robots to achieve these skills. And it's coded and modeled with Tinkercad using Arduino and lighting dynamic technologies. And here's my quick list of references. Thank you so much for your time.